Hey everybody, Adam Savage, and I'm at the American Museum of Natural History with curator Roger Benson. Roger, tell me what room we're in right now.
So we're in the room of ornithischian dinosaurs. And that's basically, there are two big groups of dinosaurs. One is called saurischians, or lizard-hipped dinosaurs. And there's some details of the pelvis that they all share. And the other is called ornithischian dinosaurs, or bird-hipped dinosaurs. There's kind of a fun fact here. You might know that birds are dinosaurs.
Yep.
And you'd think that they were bird-hipped dinosaurs.
But they're not.
No, birds are actually saurischian, or lizard-hipped
No
dinosaurs.
way.
So we're in the room that has like the big group of dinosaurs that doesn't include birds.
Oh, wow.
Yeah, and they're mostly like small to big herbivores of lots of different shapes and sizes. So things like Triceratops is an ornithischian.
Okay. Oh, wow. Every one of these cases represents so many hundreds of person years of work and labor and obsession.
Yeah, I mean, when you come here, when I walk around here, I feel tired. It's just super exciting. But you think of like the monumental work that people do.
Yeah.
Like when we go in the field as paleontologists, we look for fossils and we find dinosaurs. But actually, most dinosaurs we find are not super complete.
Yeah.
They're just parts. And that's partly because if you walked along the landscape at the time the dinosaurs were alive looking for skeletons, maybe you'd occasionally find a whole dead dinosaur. A lot of the time you'd find parts of them.
Right, because something would eat them and carry them.
Or they'd be like washed away by a stream. Other animals are interfering with the skeleton. So the fact that like most of what you're seeing here is relatively complete, that's just the tip of the iceberg of what people actually found.
Right. Oh my God, so this represents even more work than I was thinking.
Yeah, exactly. And then a lot of this was found, the first half of the 1900s.
Yeah.
And people back then, they're working hard, but they don't have the tools, they don't have vehicles at the same standard we have today. They're doing things with dynamite sometimes. They're doing things sometimes with like pack animals.
Yeah.
They're putting things on trains that go across the country. But it's just tremendous work to like physically extract from the rock. And remember, rock can be hard.
Right, sometimes harder than what you're getting out of
The
it.
skeletons of giant extinct animals and like ship them across the country. So like this was a huge like near industrial effort to bring these things here.
Incredible. So let's talk about this beautiful specimen. What are we looking at here?
Yeah, this is one of my favorite fossils that we have on display in the dinosaur halls. This is the skeleton of a hadrosaur. That's a type of probably quadrupedal herbivorous dinosaur. It's kind of a mid-sized animal. So this one, maybe it's the size of a rhino. And the thing that's really exciting about it is if you look up really close, tell me what you're seeing here.
Well, it looks like I'm seeing skin laid over his ribs.
Yeah.
Is that possible?
So it's possible and it happens. so most fossils are, we'd say just bones.
Yeah.
And that's because, bones are mineralized structure. They don't decay. Other parts of the animal decay and they're rarely fossilized, but every so often we get those other parts or some of them in the fossil. And this one, there's at least like lots of skin that was covering the animal when it was buried in the sediments that then became rock. And we're seeing the impressions of the skin covering. And there's a slightly different mineralogy that's preserving that adjacent like to that skin layer. So it looks like the animal died a little while ago, a bunch of it's rotten, but it's still covered in some gnarly soft tissue that includes skin with like tiny scales on the body.
So it's like this perfect situation of preservation.
Yeah. So things have to happen fast, or they can happen in unique chemical environments that have different pH. Or, today, if you think about like how soft tissue gets preserved in something like a mammoth, we have these fossil mammoths that are covered in fur and flesh.
Yeah.
At cold temperatures, that's not how the dinosaurs were being preserved, but it's just the point is that sometimes we have exceptional conditions, normally a fast burial by sediments in relatively low oxygen, or other factors that are allowing us to get a glimpse of the external surface of the dinosaur, not just the skeleton.
It's astounding. So I'm assuming we learn texture details about what their skin was like, but what else can we learn from the skin that we see?
So the skin impressions we have on a lot of big North American dinosaurs are telling us about the scalation of the body surface. So this hadrosaur has lots of small scales. If you look at something like Triceratops, we have a bunch of skin impressions. And some of them are quite big polygonal scales.
Yeah.
Like in a mosaic of smaller scales. It seems really interesting. One of the most fascinating discoveries of dinosaur soft tissues in the last 30 or 40 years was these amazing fossil deposits in China that have, small dinosaurs, and they're preserving the skin, but we don't just see scales on those animals, we also sometimes see feathers.
Oh.
Yeah.
Wow.
So this was like, this really sort of sealed the deal more or less in terms of establishing a scientific consensus that birds, this group of animals we see today, they're actually a type of dinosaur. Some dinosaurs are more closely related to them than others.
Yeah.
And those dinosaurs have feathers. A really remarkable thing is that other dinosaurs, when we occasionally get glimpses, they often don't quite have feathers, but they'll have filaments, a little bit like fur, that we call protofeathers. Those are like the ancestors of feathers.
Like a heavy hair, like a quill or something?
Yeah, sometimes like a quill, sometimes like a structure that branches into several filaments at its base, and actually probably would have looked a little bit like fur when we saw the animal in life. And small dinosaurs in particular can be covered with this stuff. So they're not scaly reptiles.
Yeah.
They're like furry, feathery animals.
Wow. What about color? Are we able to learn anything about color in the intervening several 100 million years?
Well, this is something when I was a kid, probably when you were young too. Like if you read any popular dinosaur books, it would say we will never know what color dinosaurs are. And like scientifically, I think you're really tempting fate when you say something with absolute certainty like this. So one of the remarkable things is on a microscopic structure, one of the types of pigments that we get in living animals that occurs in fur and feathers is called melanin. And melanin occurs in tiny cell bodies called melanosomes. And the interesting thing about melanin is that it's like, some soft tissues decay rapidly, and some soft tissues actually take a really long time to decay. So wood is an example, but melanin is also an example.
Of a soft tissue that takes a while.
Yeah. Wow. So every so often we do get either maybe like the transformed but original melanin cells, the melanosomes, or we get their casts that are preserved on a microscopic scale, surrounded by sediment. Now you can't quite tell what color an animal is from that, but you can tell what type of melanin occurs. Because different types of melanin have different shaped melanosomes. Yeah. And that basically tells us whether they've got a kind of reddy brown color melanin or a more blackish colored melanin. The problem being organisms use other pigments too. So things like carotenoids that just don't fossilize at all, so far to our knowledge.
So far.
So we don't,
I guess we'll never know.
We will absolutely, I don't know. Fingers crossed that we may know someday. But for now, what melanin does do is it forms patterns. So sometimes we can see the patterns on a dinosaur, even if we don't quite know the colors.
Like stripes or spots.
Right, and there are dinosaurs that are covered in like mottled markings, a bit like a chicken. There's a dinosaur called Sinosauropteryx, where there's a fossil that has the protofeathers and stripes along its tail. We learned a little about countershading. So a lot of animals, like the belly is lighter than the back, and that's, it occurs in lots of contexts. It's one of the things that helps animals, large animals today, to blend into the background because they become flattened because the sun is illuminating the dark upper surface so that then it more or less matches the light lower surface. The animal is flattened, it drops into the background. So we know some dinosaurs are countershaded like that. So we actually know a lot more
about
than
color.
I think people ever dreamed we would.
Yeah. When was this fossil collected?
So this was collected in 1908.
Jeez.
And it's remarkable,
Just as what you were saying, in 1908, it was a very primitive state of preservation and transportation. It seems to be an incredible condition.
Well, people were getting there. There were a number of really highly skilled people by that time collecting amazing fossils out west. And this was collected by Charles Sternberg, who was a famous early fossil collector who collected and sold fossils to museums around the country and the world. And you've got to think what this was like for people, for him even. I mean, excavating something like this with no knowledge that it's even possible that this could happen. You've got to feel like you're getting up close and personal with dinosaurs for, very early in our history of these understandings. So these animals that, a few decades earlier were really not understood well. We knew they were there, but we didn't know much about them. Suddenly you're finding dead, gnarly animals with the skin on. And I think that's
amazing.
Pretty mind-blowing.
Dude, I think I understand why this is one of your favorites.
It's really
remarkable.
Fossil.
It's so remarkable what can be unpacked just from the shadow of the thing that existed.
It is amazing. I mean, I'll tell you what still amazes me, that there are bones in the earth. And that those bones belong to animals that lived millions, tens of millions, hundreds of millions of years ago.
Right.
And they tell us about real animals that existed, not dragons or monsters, but real animals that once existed on Earth.
And I guess if you look at the numbers, with the numbers of dinosaurs that actually existed versus the bones we found, every bone we find is like a lottery ticket.
Yeah, that's right. So like, we don't know, but there's some good estimates of how many dinosaur species were alive at any one time. And probably around 1,000 species, which is about the number of species of dinosaur-sized mammals that are alive today on Earth.
Oh, wow.
And then the dinosaurs, they were around from 220 million years ago to 66 million years ago. After that, the only dinosaurs that are left are birds.
Right.
So they were around for like, I don't know, I put myself on the spot now with the maths, but they're around for more than 160 million years. So there's got to be like millions of species that ever existed.
Right, that we don't know.
Yeah, and so far paleontologists named about 1,400 species.
Wow.
So we're just really scratching the surface in our knowledge of these animals. And
literally and figuratively.
yeah, we're scratching the surface with large tools in order to gain more knowledge of these animals.
Roger, thank you so much.
Oh,
this is
great.
fascinating.
Right.
Thank you so much for watching that video. If while watching any of my videos you like any of the t-shirts that you see me wearing, well, you can go buy them. And there's two places you can get them. First, you can go to tested-store.com, a web address that my crew laughs is one of the hardest things for me to remember in my whole brain. But now they've given me a second URL. You can now go to adamsavage.com and buy any of the t-shirts you see me wearing on this channel. And there's a whole bunch of other stuff there too. Thanks.